Hello everyone. In this video we're going to cover printf and print specifiers. So in a previous video we did some output using cout, and this is a simpler way to produce the same output. So as you can see here, we have a printf statement and a familiar hello world and the new line character here. And if we do that, let's compile here. Say printf. How about that? Here we go, and then we execute print. There we are. You can see hello world. So if you've watched the previous video, you'll see that there are a few ways now that you've seen that you can do this. This is just for standard output for the user to consume, and there are different ways depending on preference and some other things. Maybe you have a special condition that makes one way better or worse than the other. So it's up to you to choose. But in this case, printf is a valuable tool. There's a lot of things you can do with format specifiers, and so that will be a big part of what we're discussing today. So as you can see, hello world is just a literal string, and we printed that out as you would expect. So I'm going to leave that in place as we go here and just add. So let's define a string, and we'll call this HW equals hello world again. Okay, so we need our namespace for our string to be recognized. Strange formatting behavior. Okay, no more squigglies. We're good. So let's compile here and print again, and we will see nothing different because we haven't done anything with this yet, but we're back to a happy state. So in order to use this and just demonstrate one of the print specifiers that I mentioned, we will do a new printf statement, and now we're going to use a %s, and this represents a string. So above here, we're not quite done yet, but above we've defined this string HW, right? And it has this content. And so we're gonna print that out using this magic symbol. It's great. So right here we're gonna reference our variable HW here. So whatever is beyond the comma here will take the place of these specifiers in the string in order. So if you had multiples, it would be in order. So whatever the first %s, for example, would match up to the first thing after the comma. And we'll kind of get into that more as we go, but that's just a very brief rundown there. So let's compile. Uh-oh. Wait, we have an error. And what is this error? It's complaining. And the reason it's complaining is because string is not recognized by printf. So printf is a C thing, and C doesn't understand what string is. C++ does. So how do we get this to work properly? Well, it's somewhat inconvenient for strings at least, but you can do something called cstring, or str. And this will convert your string into what printf is expecting, which is a char array. And in C++, we generally try not to use those, but that's what C is expecting here. So let's try again, and now let's do our print. There we are. You can see it works happily. So although this part is slightly inconvenient for strings, it is kind of a nice little tool here, right? So you have that, you have your new line character. So we could copy this and change that, for example, and then we would have multiple prints. it's an easy way to do that. Or we could actually add another string here to demonstrate what I was describing before, where we have this comma separation. So let's put test in here, and we'll see when we compile, does that work? Look at that. So a string literal is, working properly. So printf understands a string literal, where it doesn't understand the string object here. We'll get into that later, but what object is and the reason they're slightly different. But this is a string literal, and printf will, in fact, understand it. So let's take a look. What do we get? Test, as you'd expect. And as you can see, we have two %s signs and then two things here. Now say we put another %s here. What do you think we will get? We maybe get a complaint. That's correct. Because we had a %s, but there's not a third argument here. So it's saying, hey, we see 3 formatters there, and or format specifiers, and we see only 2 things to be formatted. So that's a problem, and that's what it's complaining about there. So let's go ahead and get rid of this and save. And now we have kind of the opposite problem. Let's see what that says. Same thing, or a similar thing at least. This is only 1, and we're giving it 2. So it doesn't like that. Can't do that. If you specify 1, you can only give 1. If you specify 2, you have to provide 2, and not fewer or more. So let's go ahead and remove our test here and recompile, and what do you know? Back to happy. Okay, great. So now we have that. Alright, next is a numeric specifier. So say you want to print an integer, your full, we'll put your name. How about that? So I am %d years old. And what is %d? That is the specifier for an integer value. And so let's say we're 21, although that's slightly untrue. We'll just pretend for now. Okay, so let's go ahead and compile and print, and what shall we see? I'm 21 years old. Excellent. What did we forget? Our new line character. That thing is always there. Okay, so that's another example of a numeric value. Let's see what else. There are a couple others. So let's try something with a real number instead of just an integer. But we can't have years old. Well, we could. Let's say I am 21.4 years old. Compile and print, and what shall we see? Look at that. A big long number. F here is representing a float variable. So right here, this is just a literal version of that, but we can change this into real age equals 21.4. And what will we get here? Will that work? There we have it. So why do we have so many numbers following the 4 when we only have 21.4 there? Why so many? Well, those are part of the specifier, and that's what it's kind of defaulting to. But there are ways to limit what you see that in that printout. And so here are a couple other kind of cool techniques you can do. So let's first do the limit. Okay, so say we want to, what should we limit to? 1 second here. I think it's a dot is what we want. So say we want to limit this here to 4 characters after, or maybe it's 4 characters total. Let's find out. Here we go, and there, and what do you know? 4 after the decimal. So let's do that again, and we'll change that to 2, and then we should see a change here, and there you go. So dot and then a number gives you the precision after the decimal point that you would like in the case of this. And in the case of a string, let's borrow this. Let's make a new string here. We'll say this is a test. And, well, we'll actually make this the S. That doesn't make sense if we do it the other way. And here we're going to say test. If I can type, save that. Let's go here and compile, and we should see this is a test. Now say we want to do something like this here. What do we think will happen? There are no decimals, so will it work? Look at that. It's kind of a weird thing, but it will trim to that number of characters. So if for some reason you only ever wanted something to be 2 characters long, no matter what was passed in, only the first 2 characters, for example, this is a way you could do such a thing. Okay. Okay, let's cover one more thing that would be of interest, which is making the size a specific size no matter what. So let's say you always want your number to be a certain length. Okay. Let's do something like that. And even though our number isn't long, let's do 1, 2, 3, 4. Okay, so that is a 4-character long number. 1, 2, 3, 4. Okay, so what if we want that to appear as a larger space for some reason? So say you have multiple numbers and they're up to 10 characters long, for example, and you always want to show at least that amount of space so that you can get them to align properly. So there's a way to do that as well. So with the D here, what is our number here? I think it's a +5. If I'm correct. Let's check that. Nope. That was incorrect. What did I do wrong there? What was I thinking? Maybe that was for the other specifier. The I think we don't need the plus. I think that's where I went wrong. Here we go. There, now you can see. I guess it was there too, but we added a plus, so it was kind of hard to see. But now there's a little bit more space. So if we scroll up here, you can kind of see there's only this amount of space here. And there's a little more now. It's up to 5 characters, but that's only 1 extra character in this case. So let's do a larger number. Let's do 10. Compile and print. And there you go. Much more noticeable. So now let's just do a quick, we'll do something like this, kind of for demonstration purposes. Let's make this a shorter one and something like that. Okay, so now this will kind of make more sense why this might be valuable. You can see no matter what the number, you always have that same number of spaces, right? And so it always aligns properly here. So for certain output, you know, that would be fantastic. It'd be valuable. And there's a lot more of those types of things that you can dig into, but this is just kind of an introduction here. But yet again, another way to print a bunch of fancy stuff to the terminal, which is just what we love to do. Alright, well, that kind of covers what I wanted to touch on this video. See you in the next one. Thanks for stopping by.